All right, folks. A soccer player kicks a rock horizontally off a 40-meter high cliff onto a pool of water. If the player hears the sound of the splash 3 seconds later, what was the initial speed given to the rock? Assume the speed of the air of the sound is 343 meters per second. So let's write that down. The speed of the air, I don't know. So the speed of the air is going to be 343 meters per second. And you have a guy. There we go. You kick the soccer ball horizontally off a 40-meter high. So let me write that down. So this is going to be 40 meters. So I'm going to call that H. H is specifically 40 meters. And he kicks the ball. It lands into a pool. So this is going to be the motion of the thing, of the ball. And then after that, so I'm going to let that at t equals 0 is when he kicks the ball. T equals some seconds, which I'll call t1, I guess, or t naught. It doesn't really matter. I'm going to call that t naught, is when he hits the pool. And then from t naught to t1 is when he hears the sound. So if the player hears the sound, okay, what is this asking for? What was the initial speed given to the rock? Okay, so I encourage you guys to pause this video and to give this problem a shot. Now, let's just set this up. So this is going to be the vector. I'm going to use I hats and j hats, I guess. So the vertical component, when it travels from the initial height, has some initial height plus 0 minus g over 2t squared over 2. G is the gravity, of course. So g is going to be 9.8 meters per second squared. So that means that at t naught is when the height is 0. So therefore 2h divided by g, the square root of the thing, is going to be t naught. So that's going to be t naught. So we just found the time it takes for the thing to reach this sound. Now, the time it takes for this ball, for the air to propagate through this, which we're going to do it at the shortest path, which is going to be this path, which is realistically it's going to go in all directions, but we're going to do it in that pathway. That's when you're going to hear the sound, and that sound is going to be from t naught to t1, so that's going to be t1 minus t naught, I guess. So I guess since if we're going to call this t1, that means that x, can we find x, I guess? X would be v naught t, which we don't know. So let's write that down. So x is going to be v naught times the time it takes. This is just a general equation. So that time it takes is going to be, well, we're not going to know what that is, but we do know the height, and we are going to be given this equation here. In fact, I think that's what we're going to be finding. We're going to be finding that distance d. Oh my god. Alright, so this is going to be the distance d here that we're going to be looking for. And that d is going to be specifically, is going to be 343, the speed of the air, times the time interval between t1 minus t naught. And we do know that t1 specifically, he hears it at 3 seconds later. So right off the bat, you can solve for t naught. You already know what you're given t1. You can find the distance d. So let's get that. So here t naught is going to be 2.86 seconds approximately. However, I do like to store this in my TI-84 calculator, so I'm going to put the exact value. So that's going to be 3 seconds minus that. So 3 seconds minus that would be 343 meters per second multiplied by the difference between the time interval, 0.1428 seconds, around there, or 29 if you want to write it that. So 343 times that would be the distance d. So that's going to be, so we just found that, so once you put this in here, the distance d is going to be 49 meters apparently. So that means that if d is going to be 49 meters and h specifically 40 meters, let's find what x. So x is going to be the Pythagorean theorem, d squared minus h squared. So I'm gonna write that down. I already stored these. So notice, folks, that I'm just using the applied math more than anything else. These are not really hard at all. So in fact, this is pretty straightforward, to be honest. So x is going to be 28.3 meters, and since this is going to be t naught, I'm going to use this since we already found what x is, and which x is going to be 20. Let's take it back and realize that we are given what the variable x is. So let's find the time it takes for the ball to hit the ground, and that time it takes, let's take that into the account, which is t naught, which is 2.86 seconds, and let's take that x divided by that to get the horizontal speed. So in this case, the horizontal speed of the ball is going to be x divided by t naught, or t, which is going to be 9.91 meters per second. So that's the time it takes. V times t is going to be 28.30 thing, which is x. Let me confirm this. H minus g divided by 2t squared, which should be 0. And let me see if it does. I'm just verifying this, and it does. So if that's the time it takes for the ball to have that specific height to be 0, which is 40 meters, then v times t is the time it takes for it to travel 28 meters with that given speed. So anyways, I hope this helps. All right, guys, goodbye.